Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the further integration of trigonometric functions. This is part 13 of the integration series, and I encourage you to check out all the other videos prior to this. And remember to subscribe so that you don't miss out on any of our future uploads, for we're still working on the integration series. Moving on to today's business. Recall, from the following double angle identities from the trig functions, cosine of 2x is equivalent to 1 minus 2 times sine squared x. That's one identity, implying that we are going to have sine squared x is equivalent to 1 over 2 times 1 minus cosine 2x. This is identity 1. Let's move on to the other one. Recall, for the same cosine 2x, this is equivalent to 2 times cos squared x minus 1. Implying that cos squared x is equivalent to half of 1 plus cosine 2x, and this will be equation 2. And also, for tan squared x, this is equivalent to sec squared x minus 1, and we will label this equation 3. We label these identities because we are going to refer back to them during our problem solving session. Now, let's also recall something here. We have these identities. Why? Because we are going to make use of these identities in integrating sine squared x, cos squared x, and tan squared x terms. And also, prior to this video, I encourage you to make sure that you check out all our past videos on the integration series. But today, we will mainly focus on the following videos among others. Part 1, which is the intro to integration, because we would need to make use of the way we integrate and understand how we integrate. Part 2, we also have to check out the integration, which is the reverse of differentiation, and this is something that we covered in the part 4 series. So we also have part 5, which had to do with the definite integration. And of course, part 12, integration of trigonometric functions, and among others. Now, let's dive into the first example for the day. Find the integral of cos to the power 4x dx. Now, for the solution, you would recall that the integral of cos to the power 4x dx is equivalent to or equal to the integral of cos squared x squared. So, from the laws of indices, we know that we can actually express this cos to the power 4x in terms of that. Now, with that in mind, we are going to make use of the identity 2 or formula 2. Now, we are saying that that would be equivalent to the integral of, in brackets, half times 1 plus cosine 2x all squared dx. Now, when we expand this further, we are going to get 1 over 4 integral of 1 plus 2 cos 2x plus cos squared 2x dx. Take note, we still have a cos squared term, though it's a bit different from what we had initially. So how would we go about this? It will be interesting to see how we move on from here. Now, applying identity 2 or formula 2, the one that had to do with the cosine squared x, this time around, we just substitute where we had x, we have the 2x. So with that, we are going to eventually have 1 over 4, the integral of 1 plus 2 cos 2x plus half plus 1 cos 4x dx. And expanding the bracket further, we're going to have that part. And of course, we combine 1 and the half, we get 3 over 2. After that, we simplify our work so that we have that big chunk over here, which is integrated, plus the constant of integration, which is the c. And simplifying further, what we would have is 1 over 4 times 3 over 2x plus sine 2x plus 1 over 8 sine 4x plus the c. That's how we find our answer. Now, let's look at example 2. So the first part of example 2 is show that sec squared x plus sec x tan x is equal to 1 over 1 minus sine x. Great. Recall, we are going to make use of something over here. Sec squared x is equivalent to 1 over cos squared x, and sec x tan x is equivalent to 1 over cos x times sine x over cos x. Now with that, simplifying and adding the two fractions, we would have 1 plus sine x over cos squared x. And recall from the identity of cos squared x in terms of sine squared x, we are going to have sine squared x plus cos squared x is equals to 1. And then we can make cos squared x to be the subject of the formula so that we end up having 1 plus sine x over 1 minus sine squared x. And recall from the quadratic factorization video, which I encourage you to check out, we can see that when we simplify the denominator by factorization, we are going to have it as 1 plus sine x times 1 minus sine x. And of course, the two terms in the denominator are multiplying, and one of the term is the same as the numerator, implying that these two can cancel out. When we cancel this one out, we are now going to have our final answer as 1 over 1 minus sine x, which shows what we were given in the first place. With that, let's move on to part B. So with part B now, what we have is y is equals to sec x. But before we move on, it is important for us to recall some certain concepts in differentiation. If we have y is equals to f of x to the power n, the derivative of that would be given by dy dx is equals to n times f prime of x times f of x to the power n minus 1. So with that in mind, let's apply this in the function that we're given, sec squared. Now recall, sec squared is the same as cos x to the power minus 1, implying that our f of x here is cos x, and our n is a minus 1. So plugging in this into the dy dx formula that we have above there, we would then get our dy dx being the minus 1, which is the n, times the minus sine x, which was the derivative of the f of x, and the cos x, which was the f of x to the power minus 2, or minus 1 minus 1. And then simplifying that, we would get sine x times 1 over cos squared x. With that, we can actually separate the cos squared x into cos x times cos x, so that we have sine x over cos x times 1 over cos x. With that, we can show that this becomes sec x tan x. So with that, we show that part B to be that. Great. Let's jump on to the part C. Take note, we have the word hence. So hence simply means that we are making use of what we have derived before the question. So what we derived in A and what we derived in B is going to be of great importance in answering this part of the question. So from part A, we see that we have 1 over 1 minus sine 2x is equivalent to sec squared 2x plus sec 2x tan 2x. Then with that, it means that for us to find the derivative from 0 to 1 over 6 pi or 4 over 1 minus sine 2x dx, this will be given by factoring out the 4 and having what we have inside there, which is the 1 over 1 minus sine 2x. But this time around, where we have x, we're just simply substituting 2x so that we have that expression over here. Now with that, from part B, and also if you have sec 2x, the dy dx of that would be 2 times sec 2x tan 2x. Great. So implying that if we find the integration now, we are going to make use of the 2 that we have obtained already. And take note, initially we have 1 over 1 minus sine 2x when we factor out the 4, but we still need the 2 inside the integral function and divide by the 2 because we don't have the 2. We are just introducing the 2 and divided by the 2 so that it doesn't change the question, but manipulating the question. So with that, we have this bit. And of course, with this bit, what it means then is that we can also recall from the integration as the reverse of differentiation video, as well as the other videos that we did in the past. We know that integral of sec squared x dx is equal to tan x plus c. So we're going to make use of this logic over here. Then what it means is that for the integral from 0 to 1 over 6 pi of 4 over 1 minus sine 2x, this is going to become 2 times all multiplied by the 2 tan 2x plus sec 2x, and of course keeping the limits for now. We go on to substitute the limits, starting of course with the upper limit and subtracting the lower limits. So with that, we are going to have this bit. Then simplifying further, we are going to have 2 times root 3 plus 2 minus 0 plus 1, because when we evaluate this at those particular limits, that is what we would get. Then simplifying further, we can see that the integral that was given in C is equal to 2 times 1 plus root 3. Great. Let's jump into example 3. So with example 3, what we have over here is the use of identities. And recall, when we have sine of a plus b, what it would give us is sine a times cos b plus sine b times cos a. Then we are saying that for sine 5x plus 2x, this can be expressed as sine of 5x times cos of 2x plus sine 2x times cos of 5x. The same goes for sine 5x minus 2x. This will be equivalent to sine 5x cosine 2x minus sine 2x cosine 5x. Right, this implies that sine of 7x, remember, we'll be adding the 5x plus the 2x plus the sine 3x, where we would be subtracting 5x minus 2x so that we get the 3x. This would give us what we have here, the sine of 5x plus 2x minus the sine of 5x minus 2x. Then, with what we obtained earlier on, we simply substitute so that we add the 2. When we add the 2, what we would get then is 2 sine 5x cos 2x. and that will be our answer. That's how we show that sine 7x plus sine 3x is equals to 2 times sine 5x cosine 2x. Great. With that, let's move on to B. So with B over here, we are just making use of what we obtained from part A. So then the integral from 1 over 6 pi to 1 over 3 pi of 2 sine 5x cosine 2x dx would be given by the integral from those limits of sine 7x plus sine 3x dx. Right. We also know that we covered some of these concepts in our trigonometric integration video part 12, and I encourage you to check this one out because there's a lot that we covered in that video. Now moving on, we know that when we integrate that, we are going to have minus 1 over 7 cosine 7x minus 1 over 3 cosine 3x, keeping the limits. From there, we substitute the limits. Remember, from the definite integrals video, we start with the upper limit, we subtract the lower limit, and evaluate. So as we evaluate, we get that. And simplifying what we got, we are going to have minus 1 over 14 minus 1 over 3 plus root 3 over 14. And simplifying further, we would have that. And of course, taking in the negative sign, eventually we get to what we were given on the right hand side of the question. That is 11 minus 3 root 3 all over 42 as our answer. And that's how we show it. If you've made it thus far in the video, congratulations. I leave you with the following task. Show that cosine 3x is equivalent to 4 cos cubed x minus 3 cos x. B. Hence show that the integral from 0 to 1 over 6 pi of 4 cos cubed x plus 2 cos x dx is equal to 17 over 6. Let me know in the comment section how you solved this problem. And remember to subscribe, like, and share so that you don't miss out on any of our future uploads, both for the integration series as well as other topics. Thank you so much for watching Numbers Simplified.